The rise of quantum computing, explained for beginners. Quantum computing sounds like a complicated buzzword, right? We're going to explain it in simple terms, so you'll understand how quantum computers are set to change the world. Let's start with the basics. The computers we use daily, like your laptop or smartphone, are called classical computers. They process information using bits, which can be either a 1 or a 0, like flipping a switch on or off. Quantum computers work differently. They use qubits, which can exist as both 1 and 0 at the same time, thanks to something called superposition. This allows quantum computers to process much more information simultaneously. Why quantum computing matters now? Why is this important? Because quantum computers can solve problems that are nearly impossible for classical computers to handle. Let's take an example. If you're trying to solve a super complex problem, a classical computer would go through each possible solution one at a time, which could take years or even centuries. A quantum computer can look at all those possibilities at the same time and solve the problem much faster. This speed and processing power could help solve problems in fields like medicine, logistics, climate modeling, cryptography, and more, things that are too complex for classical computers to tackle efficiently. Key quantum concepts: superposition, keywords and quantum speeds. Let's dive into the core ideas of quantum computing. First, we have superposition, where qubits can exist in multiple states at once, allowing quantum computers to process many calculations at the same time. Then there's entanglement. This is when two qubits become linked, so that when you change one, the other one instantly reacts, even if they're far apart. It's like having an invisible connection between them. Finally, there's quantum speed, also known as quantum advantage. Quantum computers are designed to solve specific problems much faster than classical computers ever could. So, what can quantum computing actually do for us? A lot. In medicine, quantum computers could help design new drugs by simulating molecular structures more efficiently than classical computers. They can also help with optimizing complex systems like supply chains and financial markets. In cybersecurity, quantum computers can both break and create unbreakable encryption systems. And when it comes to AI and machine learning, quantum computing could speed up the process of analyzing massive amounts of data and finding patterns. Current challenges: even though quantum computers are incredibly powerful, they're still in the early stages of development. Right now, they're extremely sensitive and need very specific conditions to work, like ultra-cold temperatures near absolute zero. Plus, they're prone to making errors, and maintaining qubit stability is a major challenge. But companies like IBM, Google, and Microsoft are investing billions into quantum research, and progress is happening fast. They're working on making quantum computers more reliable, scalable, and practical for everyday use. The future of quantum computing. So, what's next for quantum computing? The future is incredibly exciting. Imagine a world where quantum computers help scientists discover life-saving medicines, secure our data with unbreakable encryption, and even tackle global challenges like climate change. While we're not quite there yet, the future of quantum computing is getting closer every day, and it has the potential to transform industries, economies, and even how we live our daily lives. In conclusion, in summary, quantum computing is still in its early stages, but it's set to revolutionize the world. With its ability to process information in ways classical computers can't, it could unlock solutions to some of the biggest problems we face today. Thanks for watching. If you enjoyed this video, don't forget to like, comment, and subscribe for more easy-to-understand tech breakdowns. Until next time. The rise of quantum computing.